everybody. Oh, hey, hello. Can you hear me? Am I on? Oh, awesome. Hey, everybody. Got some Keanuception going on with my movie. I'm very excited to be talking to you all today, and I'm happy that I got you after a break so you're not hangry and possibly going to throw things at me while I'm on stage. I'll be talking to you about the art of shifting left and why it's important as a skill set for you to implement for your developers. I won't talk about product or anything, but at New Relic, we always have to include this when we give a talk. So there's nothing interesting for you to trade here, but this just says that you can't trade against anything that I'm going to talk about today. And I'll start with a story. So I am a designer that taught myself how to code. So I'm a self-taught engineer and then so on and so forth through my career. But I remember just after getting one of my first engineering jobs, I worked at a company that we had all of the makings to be a very successful company at the time. We launched a service that was right for the moment. We grew to 10,000 users very quickly, and we were converting a legacy PHP system over to use Laravel and React in an API-first environment. It was pretty cool for me to be one of my first real engineering jobs. But this isn't a fairy tale. So it was really cool to be working on this project, but we were working in the worst way possible, right? We were very proactive in every sense of the word. We did not think about what reliability or performance meant. And so in fact, we knew our services were down when we got messages on Twitter saying, hey, your applications suck and I can't log in, right? So as an engineer, in that moment, I was like, please, God, let it not be a thing that I ship to production. Please, not me, right? And as I grew through my career, I would always think about this experience and what it meant for our customers and our users. It's just like you lose trust. People are, exiting your company, your service. They're never coming back. And that's because we just wasn't thoughtful about the way that we were actually building and shipping the software out into the world. And I think everyone in this room, the story is kind of valid because in some way, some shape or form, we're responsible for building and shipping software somewhere out in the world, right? And so the way that we're thinking about it and planning that work is very important, right? So, but if you were to ask your developers, for the most part, instead of dealing with situations like the one that I just explained, they would really want to be building and shipping amazing products pretty much 99% of the time if they could. But of course, we all are put in situations to where problems arise, something breaks, we have to go and fix it, we have to deal with tech debt and make decisions as engineers and engineering leaders on what we should be working on when. There's a narrative of it's not my problem, right? Worked in dev and now it's ops fault. But the world is changing in the way that we build, ship, and own software. Things like you build it, you run it comes into play, where development teams are largely responsible for owning the deployment and the performance of their applications in production now. It's no longer ops problems. The concerns of a developer, our responsibilities are growing. And then the work that we're doing, the expectations are growing as well, right? So we're asked to ship product faster. Applications are becoming more modern, more complicated. It's harder to understand what lives where, what's being shipped out in production. Not only do we have microservices, but now we have micro front ends that we have to think about, right? We're expected to drive outcomes. So not only are we engineering and building tools, but these things have business impact, and we're expected to understand how the code we're writing is impacting the business bottom line. And we have to do all of this with less errors, right? So it's changing quarter over quarter, year over year. And in that traditional sense of building an operating system, when you're in a situation where you have to solve a problem, something breaks or something goes down, we tend to be working in the traditional model, which is what I'd say right, where you're acting reactively. So something breaks and you have to figure out what broke and then you go and fix it. You're dealing with a lot of noise, and you don't have enough context, right? You didn't think about the situation happening in advance, and so there may be some steps that you skipped because you went straight into production. You did some testing, but some things just weren't a concern. At the moment, we'll worry about security when we get there. All right, so this talk, I'm going to talk about shifting left your software development lifecycle. For the most part, I'm going to focus on observability and security practices. There's some testing practices that can come into play as well, but I'll clear up a few of the things that I'm going to talk about. So what is shift left? Why should you care? And how do you do it, right? So shifting left is an approach where you take concerns that would normally come later in your software development lifecycle and you move them further along, like towards the left of that process, thinking about them in your design and plan in your coding phase versus shipping into production and then having to figure things out later. So for my talk, I'm going to talk about the software development lifecycle in the sense of having a requirements gathering phase, right? So your design phase, a development phase, your testing, deployment, and your production phase, right? Your maintenance, things of that nature. And then for each step in that phase, I'll talk about some considerations that you should think about along your journey. All right, so this is the idea of shifting left, right? So in a traditional model, you will go through your plan and design phase, you build your software, test it, and you ship it out into production, and you deal with issues as they arrive. You deal with understanding performance of your application as you get into the space to where you need to. But what happens is as you move along that phase, you actually get users using your application. You start to get errors, things go down. You're not paying as much attention to quality as you were in the beginning because your concerns have grown, right? If you start to shift some of those concerns to the left into a shift left model, you're starting to think about things a lot earlier in the process to where you're paying a lot more attention to quality. You're not dealing with users yet. You haven't gone into production. And so in each step of that journey, you have a better opportunity to be a bit more attentive and to create more reliable and more performant software. So that looks like taking things out of that monitor and analyze phase and moving it way over into the plan and design phase. As a software developer, this means integrating observability and security considerations earlier in your software development lifecycle rather than treating them as an afterthought. So you ensure that your applications, your infrastructure, your deployment pipelines have been thoughtfully designed and instrumented and provide you with the right data that you're going to need through each step of the process that will allow you to deal with bugs faster. And some of the benefits is that on the business side, this gives you an opportunity to start being a bit more proactive in the way that you make decisions around what your team should be doing versus waiting and being reactive. All right. So I mentioned observability a few times. I do work at New Relic, and that's what we do. I'm not going to talk about the product, but I do want to clear up this term. So what in the world is observability? Observability is the process of using the data that's coming out of your application to make decisions about, it's using the data that's coming out of your application to understand what's happening in your app, why it's happening, and how it's impacting your users, and then using that data to make decisions as you go along. This concept can be applied to anything realistically. So if I were to think about a car that we drive, most of us probably have drove or been in a car at some point. You could think of observability as your dashboard on the car, right? So as you're driving your car, you don't have to stop and get out and get under the hood to figure out what's going on. You can look at the dashboard. You can see how fast you're going. If you have issues with your engine, you can see if the engine's running hot. You can make decisions around the performance of your automobile just by looking at that screen. That's observability in the core sense of what it means. And you can apply it to various industries. I can see companies starting to apply it to engineering teams and metrics about just performance of the human that's on the team as well now, right? And so this is going to be a roadmap of all the things that we may want to be thinking about as we shift left, mainly focusing on security and observability. And let's take this journey together. All right, so the first stage of your software development lifecycle is your plan and design phase. This is very early in the beginning. You haven't even opened your IDE yet. And here's some of the things that you should be thinking about, right? So for your plan and design phase, it's imperative that you involve your stakeholders, your end users, your business analysts, your subject matter experts. You get all of your key stakeholders at the table and you have a conversation. In this conversation, you want to get an understanding of what you need to build, focus on your desired outcomes, your use cases, start to think about potential edge cases, right? It's in this phase that you should be having conversations about what does reliable mean? What does performant mean? What are my KPIs going to be for this service that we're providing to our users? And though I haven't written a single line of code, I'm thinking about the end experience, right? And I'm starting to make some decisions around what my key metrics would be, and I can start to plan for how I need to track those metrics, right? You're going to perform design reviews in this stage as well to identify any potential issues and bottlenecks before you ever move into your coding phase. So for observability, it's incredibly important in this phase to consider your requirements for capturing those key metrics. which observability process or tools do you use? Do you want to use a vendor? Are you going to go open source? Are you going to use something like OpenTelemetry and Grafana? What logging systems? What type of tracing capabilities do you need in this phase? You identify those key metrics, those logs, those events that need to be tracked, and you start to incorporate them as you plan out your software. So when you get in your coding phase, you can actually instrument your applications to capture those metrics in a way that they'll be useful later in the process. For security, you do the same process and think about your security requirements. What industry standards do we need to follow? Compliance and regulations and best practices that are going to apply to the software they're going to build. You determine your security-related functionalities and control systems that need to be in place. You conduct threat modeling in this stage. You identify potential risks and vulnerabilities, and you design your control systems such as user authentication mechanisms, control policies, encryption protocols that you may want to follow, all within the system architecture that you're starting to build. And this is all done earlier in the process, right? So now I have an idea of what I'm going to build, what performance looks like, which metrics I need to use, and then how do I kind of want to keep this application safe and secure. Once that's done, you start building your application and you move into your develop and your build phase, right? We got our IDEs open, and this is where we really want to live at, and we're doing the interesting part of the work, right? So in this phase, you embrace your best coding practices. You establish industry-leading coding standards to ensure that your code's going to be maintainable and reliable. You implement strategies around documenting your code, so folks that come later, or even yourself, when you need to update something later, you have documentation that'll help you along your way. You conduct code reviews to catch any bugs, any security vulnerabilities, or performance issues earlier in the process, right? You can do things like interactive code security testing at this stage. I jumped the gun. I need to get into the security phase. But in this phase, you start to implement some of the practices that you made your decisions on in your planning phase. For observability, you implement your monitoring, your logging frameworks and library to capture your relevant logs and events. You instrument your code with appropriate metrics and track system behaviors that will track your system behaviors and outcomes. You make decisions around your tracing, right? If you're building microservice-based architectures, you need to know how your services are communicating with each other, and so you're implementing a tracing strategies to reduce any issues later that can lead to performance bottlenecks. And then for security, like I said, you can do interactive security testing. So testing your code as you're building it to avoid things being shipped into production. You apply secure coding practices and guidelines, and you minimize any chances for vulnerabilities, making decisions around the packages that you're going to use as you're building your software to reduce the chance of implementing packages that already have noticeable vulnerabilities, right? You do secure communication protocols, input validation, and output encodings using secure libraries and frameworks that'll help you avoid any common security challenges. Once you've done all this work as you're building your software, you're ready to go into your testing phase. One of the most important parts of testing is that you want to test as early as possible, doing things including unit tests, integration tests, and functional testing. And you want to leverage automated testing frameworks as much as possible to increase your test coverage and enable continuous testing if possible. For observability, while you're testing, you want to make sure that you have access to the right data that will let you know your system's performance before it ever gets into production, right? So as you're running your tests, do I have my capturing the right metrics that I made my decisions on in my planning phase? You validate your log outputs, you monitor your system metrics as you run your tests, and you also pay attention to your trace requests to ensure that your services are functioning properly. For security, you conduct security tests, including vulnerability assessments, penetration testing, to identify and address security weaknesses. You test for common vulnerabilities such as ingestion attacks, authentication bypasses, and you make sure that your configurations are secure for the applications that you're going to be building, as well as you want to make sure you're doing some of this testing for your deployment processes as well. Once you've gone through your testing phase, you've automated as much as possible, you're ready to go into your deploy and release phase. And this is where you're going to automate your deployment process to achieve a frequent and incremental deployments, right? So reducing the amount of code that you include in your PRs, getting as many deployments out as frequently as possible using an automated system that's going to allow you to have a more reliant deploy and release process. You perform smoke testing and validation inside of a staging environment before you ever deploy into production. And then with observability, you automate the deployment process to include your observability components as a key part of your deployment pipeline. Right, so once you start to operate your systems and your services at scale, you could be deploying multiple times a day, spinning up various environments. And as you spin up a new environment, you want to make sure that your instrumentation is there, that your dashboards are going to be available. You can use tools like Terraform to deploy dashboards for you, to build alerts for you out of the gate. So you don't have to worry about this once it's in production. It already exists, right? So you implement those same practices that you make your decisions on and some of the work that you've done in your coding phase into your deployment process as well. So you can ensure that your logging, your monitoring, and your tracing systems are correctly deployed and configured out of the gate every time in every environment. For security, you apply secure deployment practices, including securing your configurations for your servers, databases, and network infrastructure. You encrypt your sensitive data and make sure that you protect credentials and employ secure transportation protocols for your data transmission. And that's going to be key in this phase, that you do those steps. Once you've done all this work, we've gone through our plan design, we've built the application, we've tested it, we've gone into a deployment process, we've ran our smoke tests inside of our staging environments, and now we're ready to go into production, right? This thing's ready to go out into the world, and this is where we get a rush of users and all of the weird things can happen. So it's incredibly important at this stage to just be paying attention, right? So establish a robust and monitoring and logging mechanisms. Prioritize fixing your bugs, security patches, and over feature enhancements based off of your data. So at this point, you can start making decisions around, should I be focused on reliability work versus velocity on my roadmap, and using the output of these systems to make that choice. So if I've gone through and I've done things like built SLOs or SLIs that are monitoring a baseline of performance based off of all the instrumentation that I've done, before an outage ever happens, I could use that data to make decisions, right? So I have an application that's running in production. I understand what the baseline looks like because I have an idea of what success looks like, what performance looks like. Let's say if I built a shopping cart, right, and I want my checkout service to make sure that every order is processed in sub 2 seconds. When someone clicks the payment button, I need that transaction to be quick, right? I need to get that money in my bank account, right? So whether I have an outage or not, I can look at my instrumentation and say, okay, I know performance is sub 2 seconds, and I'm starting to see that my payment transactions are starting to take 3.5, 4 seconds, right? I don't have any issues in production yet, but they're not performing in the way that they should be. And so my services aren't reliable, right? So now I can make that decision on, should I be focused on new features, right? Should I be advancing my roadmap? Or should I get my engineering team in a meeting and say, hey, we have some issues with some of these services. We should figure out what's going on and get back to that sub 2 second objective that we set into place. And that's how you act proactively using this data to avoid issues, right? That's how you avoid those Sub 1 incidents and things going down by addressing them in advance, right? So for observability, continuous monitoring, analyzing your logs, metrics, and traces in your production environment. You implement anomaly detection, alerting mechanisms, and proactively identify and respond to system issues. So like I said, you can also build alerts that'll alert you on things like that, right? Your SLOs are being violated. You should pay attention to these services and go and do some work on them. And then from a security standpoint, you regularly update your software components, libraries, frameworks to address security vulnerabilities. You monitor your security-related event logs for potential incidents, and you have incident response procedures in place. All right, so it said that in 90% of our applications, we're using some form of open source package, right? And over 50% of our engineering teams are not going to update those packages once they're in production. So we have vulnerabilities and we're not doing the work to address them. And then things like log4j happen, right? So it's at the stage that you want to be paying attention to what you're running in production, and then make sure you're doing the work to go and address them, update your packages, pay attention to the performance of your applications, and provide your users with the best service possible. Okay, so I may date myself with this next slide. When I was a kid, I used to watch a show. It was Lamb Chop Sing Along, right? And there was a song that was like, this is the song that doesn't end. You all remember that? Am I the only one? Am I my friend, right? Some people start it. Okay, that's this journey, right? Because you go through all these steps and it's a never-ending process. You're always iterating. You're doing it over and over. As you build a new service, you go through every single stage of your software development lifecycle. You shift as many things left as early as possible. When you need to make a decision around your roadmap, you start to shift things left as early as possible. And you get into the rhythm of it, but it's something that never ends realistically, right? Once you started the journey, you keep on this journey. And I'm glad that some of you are as old as I am. All right. Okay, so some tips for shifting your software development lifecycle left. Foster collaboration. Make sure that you're encouraging frequent communication with your different teams and stakeholders. Automation is key. Invest into learning automation tools, frameworks, testing your code, and your deployment processes. Automate as much as possible. Within your organizations, you want to develop a DevSecOps culture, right? So that's going to be key to adopting this process. And then stay learning, stay curious. Continuous learning will allow you to stay curious and start to implement more of these early in the process. And so shifting left is a mentality shift before it's ever a change in your IDE. And I got up here and started rambling. I never introduced myself, but I am Jemiah Sius. I am a senior director at New Relic. I lead our developer experience org with a bunch of different groups reporting to me. Miami native, designer turned developer, 15 years of coding JavaScript and PHP. Lots of alcohol because of PHP. A passion for community building, love learning. I'm not interesting online at all, but that's my LinkedIn and Twitter. And thank you all so much for having me. I hope you enjoyed this talk. I look forward to chatting with you if there are any questions. Hope you enjoy the rest of your day.